Testing 1, 2. Welcome to the class. Is it Therese? You need to somehow connect your microphone or switch the microphone on or allow Zoom to access your microphone.
Okay.
And I'm putting it up on YouTube. I'll give you a link or something. Anything on this lesson, you can actually re-look or evaluate or whatever. If something you're still struggling with, you can have a look at it again.
Okay.
Cool. Let's start. Okay, we are going to restart then with vectors, as if we started the year fresh. Is that right? Good.
So we're starting with scalars and vectors then.
Yes, we're starting with scalars and vectors. We are behind, but we're going to try and catch up. Right. Okay.
Yeah.
Cool. First example. What you can do is you can take screenshots, obviously, as we are going, just to make notes taking easier. You don't have to take notes now. You can take the screenshots and redo the notes afterwards. That saves a lot of time. And that means we can do more work. Also, you can go back on the video online and then take the notes from the video. So you can stop me if you want to take notes, but I would prefer that you stop me to say, look, I want to actually do a screenshot. And then I just wait for you. So like this example now, you take a screenshot and then I explain it to you. Can you take a screenshot? You know what to do. Snip screen or whatever. Right, let's go. There's a rock on the ground. And there's a man, actually, he's taken a rope over his shoulder and he's pulling that rock with 100 Newton force at an angle of 60 degrees with the horizontal. The first thing I want you to do is work out the vertical and horizontal components of this force. So if this is a rock and someone pulls it at an angle, then basically what this guy is doing is pulling it up, and we're calling that the Y component or the horizontal component or vertical component. And he's also pulling it to the one side, which we call the X or horizontal component. And you need to be able to work that out. That's quite easy. I think you can do that. This is called the force X or the horizontal component, and the force y, or the vertical component. Right. We're going to use trigonometry. I don't know how much you can remember of that. But what would you say? Is the x component cos or sin? If you have a triangle here, and I have a 60
Yeah.
degree angle here, what
Oh,
is,
sine, cos, and tan.
yes, what is cos? Can you remember what is cos? Cos.
Cos I believe is, if I'm not mistaken, 2√3.
Yeah. Cos 60 is a half actually, but let's just say, what is cos theta? Let's just make that angle quickly theta there, or alpha. What will cos alpha be? Cos alpha will be adjacent over hypotenuse. Is that correct?
Yes.
So this is my x component. This is the 100 Newton, and this is my y component. So cos alpha will be adjacent over hypotenuse. So the fx component, if I multiply with 100 right through, will be 100 cos alpha. And the y component is opposite over hypotenuse, so it's sin. That will be 100 sin alpha. Take
Okay.
a screenshot of this.
Okay.
This is very important. If you cannot get the components and the bit of grade 10 trigonometry right, then you are going to be in big trouble. Okay, screenshots done. Right, so the first question is, let's calculate the horizontal and vertical component. So you're going to learn that the horizontal component is, just want to rewrite that. The horizontal component is the force, which is 100 newtons, times cos the angle. And I put that in my calculator. That is 50 newtons. And because force is a vector, you must also give direction. And if I give that direction on this axis of, then that will be east. I don't need to explain that. North, east.
No, we learned that last year.
Yes, very good. And then the
And
y
also it's a
component,
basic geography thing.
yes. The y component will be 100 sin 60, and that's harder to do in a calculator. That will be 50√3 or something. But in
I
science,
believe so.
we have to use decimals.
Yeah, 50√3, or it is 86.60.
60 Newton, and that would be north.
Yes.
Okay, so this is just this sum was just the exercise to see if you can get do basic trig, and to see if you can actually read the directions from the axis. Okay, but this is too easy, way too easy. Are you with us, Michael?
Yes.
Good. Okay, let's look at this example. Let's do example 3 first. Right, I've got a certain point. It can be a tree, a stone, a block, whatever, or just a point at which wires are connected or forces. So there's a 100 Newton force. I don't know if the size of the drawing is big enough. Can you see that?
Unfortunately, I am green-red colorblind, so I can't see the arrows.
Okay, really?
Yeah.
Okay, no problem. What I'll do is I'll make the red one bluish. Can you see that?
Yeah, I can see that. And
And
then the other arrow is fine now.
this one I'll make yellowish.
Okay, thank you.
Okay, but that's very important you tell me that, because my pencils that I've chosen on the screen they're all red or green or blue. So I need to change at least one of them for you. All right. So now, basically, there's a lot of questions they can ask you, but basically what they want you to calculate is the resultant vector. In other words, if there's a big stone here, or any
Yeah.
object, and someone is pulling it upwards at 100 newtons, and someone is pulling that way with 120 newtons, and this angle here is 40 degrees, what would this stone do? It will move, probably in a direction towards the right somewhere.
Yeah.
This is called the resultant vector, or the result, or the netto, or the result of the forces. It's just called FR short for force resultant, or the result of the forces. It's called the resultant vector, or some books call it F net, the netto force. It's all the same thing, and they are all accepted. So there's a method. There's two methods of doing it. The one is using the cosine rule, which you've not done, and I'm not going to show that one to you. The other one is a method through components, and that's what I'm going to show you. So you're going to take one of the forces. Let's make the one going up north as force 1, and the 121 is force 2. So I'm labeling the two forces. I'm redrawing this drawing on my answer sheet, and I'm labeling the forces as F1 and F2. So force F1, the X component, this blue force is not pulling the stone to the right or to the left. It's just pulling it up. So it does have a 0 Newton horizontal component. Do you understand that? It is not pulling left or right. Okay, so that's fairly easy. I don't have to calculate anything using trig on this example so far. Then the force 1 also has a y component, but it's just putting straight up at 100 newtons. So there's no angle. So that is just 100 newtons north with an R somewhere. So this is quite easy.
Yeah.
Okay, now we get to the other force. If I use green, can you see this? The force 2x.
Yeah, I can see that.
Okay. So this green force, or the second force, it does have a horizontal or an x component because it's pulling to the right. And it does have a downwards component because it's pulling downwards. So we're going to work out both of those forces. The force 2 has the x component. What is the x component again? Sine or cos? So this is my little diagram. The x component is adjacent over hypotenuse, and that's cos. If you look at this angle here, the x is adjacent to the angle, and the force is the hypotenuse. I've just drawn a triangle of this little diagram. Can you see that triangle there? I've just redrawn it there. So the x component, you're going to remember that the x component is always cos. So that's the force, which is 120, times cos, the angle of 40 degrees. And that I just bump into my calculator. 91.92. Look what I'm doing. I'm using 4 decimals because I'm only allowed to round off to 2 decimals at the end at the answer. Where's your friend now? He's left.
His computer died, but he is here with me.
Okay, cool. So that is what? Newton east. It's in that direction towards the east. Okay, and then the second force's y component will be to the south, and that will be 120 sin 40. And that is 77,1345 Newton south. Screenshot. So this is like step 1. Step 1 is calculate the components of each force. So we're going to write it here somewhere. Step 1. Calculate. Oh, maybe I can try and really write nicer than that. Calculate the components of each force. Remember, there can also be 3 or 4 forces. You don't get that very often because that's just a lot of marks to give away. Because once you can do 1, you can do 3 and 4. So they're just giving extra marks away, not testing anything. All right, cool. That's step 1. So what I'm going to do, I'm just going to make this nice and small, so we can reuse the answers if we need to. Now, step 2. Step 2. What is the total X and Y values? So there's a certain way of writing it. You're writing the force result of X or total of X. You can write total X or result of X. That's what the force result X is, the one component's X value plus the other component's X value. So the force 1's X value plus the other force's X value. Now the force 1 just have a 0 X value. Plus, now you have to make a decision. Which direction is going to be positive for you? Now I'm going to choose the direction towards the east as positive, simply because that's the only X component that exists. And then I'm going to look at which Y component is the largest and make that one positive. Now the component towards the north is the highest value. It's going to be 100 compared to 77. So everything that is north has a positive value, and anything that is east have a positive value. The rest have negative values. So in other words, the force X1 has 0. Now the force 2X is a positive 91,9253. And that gives me a total value of 91,9253 newtons east. That's really simple. The next example is going to be harder. Right, so now the next part of this step is to get the result of the Y values. And you have to write, it's the one force's Y value plus the second force's Y value. You have to write this equation, otherwise you lose marks. So what is the one component? Well, the first force has a 100 Newton north, and we have decided that north is positive, so I'm giving that a positive value. Plus, the Y component of the second force has a south direction, so that would be a negative value, and that was 77,1345. And that gives me a total of what? 22, what's that? 8655. Quickly do that. Yeah. Newton north. So this is the second step completed. What is the total value of x's, of all the x's, and what is the total value of all the r's? And you can quickly do a screenshot there. Cool. Now, the next step is slightly difficult because it's something you have to like memorize to do. Otherwise, you won't just do that off by heart. And that is to make a new drawing. So step 3 is a new diagram. And that's just to help.
Calculate step 2, total XY.
Yes.
Step 3.
New diagram. In other words, I'm just going to make a new diagram. And in that new diagram, I'm going to put the total X value in. There is a new X value. I don't know if you can see that red.
That's red.
Yes. And that
Okay.
was, pardon?
Yeah, I can see it.
That was 91,9258 newtons to the east. And then I'm going to put my total.
Wasn't it 5.3?
Yes. Sorry, it's now so small that I can't really read off that screen. Okay, and then the total Y value was something like what? 22,86.
22.8655.
Yeah. It's not important that you do write all the decimals here. It's just important that you have the decimals. Remember this drawing you're making now, there's no marks in this drawing. This drawing is just to help you visualize. So certain students draw this drawing exactly the way I did it now. And then they make a resultant with a parallelogram method like that. Other students say, no, doesn't look right. They don't like it. So they prefer drawing the one component, like say for instance, the red one first, and then they do what they call a head to tail method. So they put the next vector on the head of the previous one. And then the resultant is from the start exactly to the end there. So that makes a nice triangle. With this angle here, we can call alpha. So we have the blue value as 22,8 something, and we have the x component as 91,9 something. And now you can just determine the resultant with Pythagoras. So the resultant force is the root of 91,9, I can't remember what this was,
9253.
squared plus the 22,8655 squared. And then you get the result. Let's do that.
Okay.
Have you done it
90.
yet? I get 94,73 rounded off to 2 decimals. Because I just used answer stuff.
Uh, 94.73.
Yes. Okay, now we have the answer, but we still need an angle. Now I'm going to make that angle alpha there. And then I'm going to use tan alpha, because tan is opposite over adjacent.
Yeah.
Okay, let's do that. Just put in those 4 decimals. So it's shift tan
22.8655 over
91 something.
91.9253.
That's a small angle. It's like 30.
0.24.
No. 13,97.
How did you get 13.97?
Did you type in shift tan to get the angle?
Okay. Okay, I got that.
Okay, no problem. Now it's very important. You can give the answer as 13,97 degrees. So you can do 13,97 degrees north of east. That's one way of answering. Another way is just to give geographic direction. In other words, you go all the way from north clockwise. And that will be just 90 minus that answer.
Okay.
That will be 76,03 degrees. So that's the way I use it. I just go semicolon 76,03 degrees, because that's your geographic direction. But you can use 13,97 degrees north of east also. It's also a way of answering the question. Good. Right.
You did say you were going to post this on YouTube, right?
Yes. There's what you can do, there's a channel. If you type in YouTube, if you just type in the following Wiskunde Skynat, that's Afrikaans, eh? Then you'll find there's a YouTube channel there, and your videos will under HS grade 11, something like that, or physical science. That's homeschool grade 11 physical science. All the videos that we do will be there. Okay. But what I'll do is I'll just send you a link. All right, cool. Okay, second example, boom. What is what you're going to do? You're going to screenshot this. This is homework for you. Apparently, we're going to see one another again this week. I'm not sure. Let me just speak to you.
I'll be back. I just need to get something quickly. So sorry.
You back?
That's cool.
All right. So will you be able to do something like this? Let's just go through the just quickly screenshot this.
Yeah.
Do you have it?
Yeah. Wait. Yeah, got it.
Okay, let's just go through the method. I'm not going to do the sum. I'm going to give it to you. But we just go through the 3 steps. The first step would be to take one of these forces, okay, I've really labeled it as 1, to work out its y component and to work out its x component. Then to take the other force, work out its y component and its x component. Then the second step would be to calculate the total of all the x's and the total of all the y's. So what I can see that the both y's are going upwards. So I'll just add them together and make upwards as positive. Then the one x will go to the left or west, and the other x will pull to the right, east. So you'll subtract these two from one another, choosing the one side as positive. And then you get the resultant x and the resultant y. Now, the difficult part is this is step 1. Step 2 is Pythagoras. No, it's not, eh? What is step 2? It's drawing that new diagram.
Isn't that step 3?
Yeah, sorry, I did step 1 and 2. This is step 2. This is step 2. Getting the resultant x and the resultant y.
Step 3 is a new diagram.
Step 3 is a new diagram. That's better. Step 3 is a new diagram. In other words, you get a new y value, which is the sum of the previous two. You get a new x value. And then you'll either put them tail to tail, like I've just done, or you'll put them head to tail, which most students prefer. And then the resultant would be something like that. And then you can work that resultant out with Pythagoras. And then the last step is getting the angle alpha. And then either using this angle as north from west or doing a geographic angle all the way from north clockwise. Okay. I want to actually see if you can do this example. This is a very classical, good example for exam or test purposes. Right. Okay. What
Do you
we've
want
done-
us to do that now or
No,
later?
no. That's part of homework type of thing.
Okay.
So what we've done now, very important, we've worked with vectors that are not in equilibrium. In other words, there is a resultant vector. In other words, if I have a box here, someone's pulling it in that way at 80 newtons, someone's pulling that way at 40 newtons, then the box is not in equilibrium, it's not in rest, and the box will move in that way. So there will be movement. So that's the one section of this chapter is working with vectors that are not in equilibrium. In other words, there's some movement happening. The second part is going to be working with vectors that are in equilibrium. In other words,
Okay.
the forces are cancelling one another. If I had a force here to the left of 80 Newton, this will be in equilibrium because no movement will be in. There will be no movement.
Yeah.
Right, so let's see what we have there. Examples. Example 5. This is too difficult to start with. Yeah. Okay. Right. Visualize the following. I'm just going to go away from this drawing. What you can do, you don't have to write down anything. This drawing, you can screenshot, so you have the question. And then tell me after you've taken the screenshot. Please take a screenshot.
I'm doing that now.
I think it's print screen or something, or you've got snippet if you have Windows.
Screen.
I'm just taking photos of the screen.
Okay. Then the next one is the memo. So you can screenshot that too. But I'll explain the memo. Just so you have it on, like, you can always go back to the video online and just redo it or just make the drawing. I want you to do physical notes, actually. Having everything on your phone or whatever means nothing. You have to do physical notes. But saving time is what we're doing now. Good. Right. So imagine the following. There's a rope. There's a ceiling there. And there's a rope hanging from the ceiling with a weight there. And now you taking your fingers there in the middle of the rope and you're pulling the rope that way. So what will happen is that the rope will bend in that direction. At the point where you're pinching it, you're still pulling in that direction, but this part of the rope will hang down. You can visualize that. You had a rope with a weight on it. You're taking the rope, you're pulling the rope to the one side. This is exactly what that drawing is.
Okay.
A 3 kg block hanging from a rope. A force of 25 newtons is applied horizontally, allowing the rope to make an unknown angle. And they're referring to this angle here. Okay. Use the diagram to determine the following. First question is, what is the tension in the rope section PQ? So I have a section of rope here, PQ. I want to know what that tension is. Okay, now components are very important. This system is in equilibrium. How do I know that? How do I know that?
Because the points meet at the same.
No, you can think about that, but there's if it was not in equilibrium, in other words, if this 3 kg block was moving down, I mean, it will break out of the ceiling, that part of the rope, wouldn't it? Or the rope will. If it was not in equilibrium that way, I mean, this mass piece will just move in that direction, and then the rope will break. I mean, you can't continue pulling the rope. If it's not in equilibrium, it means it is constantly moving in one direction. Now, it can't move in one direction for very long. Then the rope will either break or the ceiling would break or whatever. So this system is hanging still. There is no movement. No movement means it's in equilibrium. No movement means there's no resultant force. All the forces balance one another. That's a very important word. Equilibrium is a difficult word. Balance is an easier word. And it's not a real scientific word. But if you think of all the forces balancing one another out, talking unscientifically now, I mean, that would be a right way of thinking about it. So there's balance. Nothing is moving. Okay, now, components, there's two ways of looking at the sum. One is thinking about components. Now, I'll explain to you what components say. Components says the following, that this Q section here is being pulled down by that 3 kilogram weight. If you make a knot here where Q is, that knot is being pulled down by the 3K, and we call that force Fg. Can you remember what Fg is? It's the force of gravitation, and it's the mass times the acceleration due to gravity, g. What is small g? Can you remember the value there? You did kinetic energy and potential energy last year. G is 9,8. Okay, can you remember
Yes.
the mechanical energy? And then you add potential energy, which is mgh. That G is 9,8.
Isn't that 9.81?
Not for our purposes, no. It's 9,8
Okay.
exactly for the caps purposes. Okay, but because that rope is not moving down, or that knot is not moving down, this part is also being pulled up by the rope. Also, there's a red force of 25 newtons pulling towards the east, but the rope is countering that. So there's a back pull that the rope is doing. So I can make a triangle out of that. I can say that this is the triangle that comes out of that drawing. Q is here, P is there, and there's the angle theta. This is 90 degrees. And this force here is 25 newtons. Why? Because the force here equals...
It says so.
Are you happy?
Yeah.
And this upwards pulling is the same upward pulling here. So this force here is Fg. Because these blue forces are all the same. Downwards and upwards is all the same. So that upward pulling is the same as the downward, and that's Fg. And now I have to write, to get all my marks, Fg equals mg equals 3 times 9,8. I can give a value now, I can leave it. Let's just get a value now. That is 29,4 newtons. So that's 29,4 newtons. And now the tension in the rope PQ is quite easy to find, because you can just say PQ using Pythagoras is what? 29,4 square plus 25 square. That's that. That's 38,59. Now, tension in the rope doesn't have a direction, because it depends on where you're looking at, from what angle you're looking. If you're looking upwards, the tension is upwards. If you're looking downwards, the tension is downwards. So we don't give any direction when the question is, what is the tension? Quickly screenshot that. I'm just going to make it slightly smaller so you have the question in as well.
I've got it.
Good. That's the first question, tension in the rope. And the second question is just, what is the angle theta? And I'm pretty sure you can do that. We're going to use tan again. Tan theta is opposite over adjacent. And you're going to remember, if you want an angle, to type in shift tan or second function tan.
Yeah. Shift tan is it?
Yep, 25 over 29.4.
29.4.
I get 40,38
Yeah.
degrees. And those are the two answers. We're going to do a harder one after this.
Yay.
But I want to show you another method. This is called using components. Now with this...
So this is method 1.
Yeah, this is like method 1, but this sum is this sum is not a very good example to use to show you method 1 and method 2, because it's a very elementary sum. It's very basic. Can I wipe everything?
Yeah.
I'm just going to show you how we use the triangle rule. And then I have to teach you some new stuff, some new maths, before we can continue. Right. Now, if you use the system we call triangle rule, you can think it's exactly the same as what we've just done. I just want to get another pen. Can you see this blue?
Yeah.
Okay. Okay, so I'm going to get this triangle rule out. It's the blue is nicer. So the triangle rule. Basically, this rule, you try and find the gravitation component. So look at all the three ropes or three forces. There's a force to the right, there's a rope PQ, and there's a force downwards. So this blue one is my FG component.
Okay.
Or that's the component in one direction, basically. And I'm going to take that and like stick it on the ceiling. So I'm just going to move it and put it there.
So you're moving FG to...
Yeah, to the ceiling. I'm going to try and get it on the ceiling. And then there's one force left that's outside the triangle now. And this is this red one.
Yeah.
And I'm just going to flip it over to the other side or close the triangle.
So you're inverting it, in other words.
Yes. And then I'm just going to draw a triangle. Now, this, I know it's a bad example to use because it doesn't make sense. We've just done it. So this is 25. This is G. And this is the tension that we're looking. And now we use exactly the same method using Pythagoras. So it's not a different method. In the next example, you'll start to see the difference. Okay, cool. Let's go to the next example. Right, look at this. Right, there are, I didn't write up anything. I'm just going to explain what's happening here. We have a ceiling at the top. I'm going to make that one pink. There's a pink ceiling. Then we have a blue rope called A coming out of the ceiling and being knot here. There's a knot here. And then we have a yellow rope coming out of this end of the ceiling. And then we took a 12 kg block and we hang it on that knot. So basically what they want to know is, what is the tension in both ropes? So they can ask, what's the tension in A? They can ask, what's the tension in B? They can ask, what's the tension in both? Doesn't matter. Now I have to show you some new math before we can do this. We're just going to go to a blank page and we're going to do something new that you haven't done. It's called the sine or Syn rule. Now in the past, you have only worked with triangles that have a right angle or a 90-degree angle. This is like grade 10. That's why you can do sin, cos, and tan quickly. Opposite over adjacent. That. But what if we have a triangle that doesn't have a 90-degree angle? I mean,
so like an isosceles triangle.
Doesn't matter. This angle can be 44 degrees, and this angle can be 68 degrees. And this side can be, let's say, 15 Newton, and this side can be X. I don't know what it is. It was easy in the right angle triangle because then you can use sin, cos, and tan. But now it's kind of difficult because I have to know some new stuff. And it's called the Syn rule. Now I'm going to show you the Syn rule. Basically, it's very easy. You are just going to work with stuff that is exactly opposite one another. Can you see that X and 44 is exactly opposite one another?
Yes.
And the 15 Newton and the 68 degrees is exactly opposite one another.
Yeah.
So the rule looks like this. It says A over sin A equals B over sin B equals C over sin C. But you don't have to remember that for science purposes. We can do that in math later. Okay? All you need to know is that you're going to put the red stuff on top of one another and the blue stuff on top of one another. So I'm going to do X, because that's what I want, on top of the angle. So that's sin 44. So the side that I want to know over sin of the angle, and that will equal the combination of the stuff I have, 15 on top and sin 68 at the bottom. You can also flip it around and have the sin 44 on top with the X at the bottom, the sin 68 on top with the 15 at the bottom. You can flip it around. But in science, we always want to know what the tension in the rope is. So your Newton value or your side value will always be on the top. So we're not going to go in depth in this rule. We're just going to show you this. And then what I'm going to do, I'm going to multiply with Syn 44 right through. Why do I do that? Can you explain? Then it cancels on the left-hand side. Then I only have x left. And then I multiplied on top there, 15 Syn 44. Is everyone with me? This is just a little bit of maths. If I have x over 2 equals 10, what would the answer be? 20.
No.
Yes. I want to just get rid of this fraction. That's all I want to do. I want to get rid of the 2 underneath the x. So I'm going to
Well, you'd have to divide. No, yeah, sorry.
I just multiply both sides with 2. Then those 2 cancel. Then x remains. And 10 times 2 is 20. This is exactly what I did here. I multiplied both sides with Syn 44. And you can think of it as Syn 44 on 1a. So they cancel. And then the Syn 44 jumps on top there. That's like, okay, I'm pretty sure you can do that. Now, just type that in your calculator as is. No second functions, because I don't want angles. I have angles. So it's 5 Syn 44. Just close your bracket.
5 Syn 44
Over the Syn 60.
over Syn.
And then we'll look at the answer to see if it's realistic. That looks a little bit. Is it it's 50, not 5? Somehow I deleted that 1. I get 11,24 if I use 2 decimals. See if you get that.
Yeah, 11 over 24.
11,24.
Yeah, sorry.
Okay. Just screenshot this. This is kind of important.
Okay.
Let's go back to the example. So I'm going to show you the triangle method. So I'm just going to get all these colors away. I'm going to take the gravitation part. There we go. That one, eh? You agree?
Mm-hmm.
And I'm going to stick it on the ceiling. Boom. There it is. It's called FG. Make it long. Oh, this was not the wrong side, but the hardest side to do. And then I've got this green force here, which is tension in the rope.
Mm-hmm.
I have the red one, and this blue one I'm just going to pull down. Here's my triangle. So this is B.
Okay.
This is A, and that's FG. But now I have to find angles. Okay, this angle here on top is fairly easy. That's 50 degrees. Because it must be 90 with that 40. Agreed.
Yeah.
Then there's various ways of looking at it. Certain students want to get this angle next, and that is 100 degrees, because it's the exterior angle of this triangle. You agree?
Mm-hmm.
And that is the sum of the 2 interior triangle angles. So those 2 interior angles give me that 100 degrees there. 100. And then 50 plus 100 plus another 30 gives me 180.
Yeah.
Good. So now I have a big triangle here. I'm just going to redraw it. With 100 here, 50 there, 30 there, FG there, B there, A there. And now I'm going to use the Syn rule. I'm just going to get FG first. FG is mg, and that is mass times 9,8. Now just get that value first. And that is 117,6 newtons. Okay, cool. So now let's set up the Syn rule. I'm going to do A over that and FG over that. Remember, I want to know what A is. So A goes on top over Syn 30. And that equals a combination of what I've got, which is FG over 100, which is 117,6 over Syn 100. Then I multiply with Syn 30 right. Give me a second. Do you understand what I've done?
Yeah.
Okay, let's type that in the calculator. Are you still with us?
Michael is still here.
Sleepy Michael?
No, he's not. He's trying to understand.
Is it helping a bit?
No.
Not.
What did you think?
Michael, speak to me.
Yeah.
Is this lesson helping you a bit to understand vectors? Not.
Son of 100. 59.71.
And then B over Syn 50 is equaling FG over Syn 100. Do that. $91.48. Do you get some other value?
You said 117.6 over sine 100, right?
Where's the sine? Yeah, but what 117,6 times sine 50. Remember, we also
You said
multiplied.
divide.
We also multiplied it with sine 50 again. So B is then 117,6 sine 50 over sine 100.
Okay.
You can type in this part of the sum first and then multiply with sin 50 afterwards. It's not going to matter.
91.48.
Yes. Okay. We can't do the other method. We don't have time for that today. But what I'm going to do, I'm going to allow you to just photograph. This is method 1. So this is the triangle method. Okay. Just take a shot of that. And then you must make a note that if I see you again this week, apparently you want to do 2 lessons a week. Is that correct? Or you haven't?
Yeah, as I said, let's do this one trial and then take it from there.
Yes. Okay. And then this is the component method. It's much harder, much longer. But you can just photograph that as well, because I'll probably have to go through this one too.
Okay.
Okay. So what's going to happen? I think is your tutor's name Trish?
Yes, she's here with us right now.
BBC contact me to make sure that you're happy with the lesson, want to do more, what we're going to do, and how we're going to play around. Okay. Then.
Yeah, I'll give you a call later this afternoon if that works for you, Charles.
Yeah, I'm going to just be in classes from around 4 o'clock till 8 o'clock tonight.
Okay, I'll try and give you a call before that. Otherwise, what's your schedule tomorrow morning?
I'm not sure. I've got I've got Mondays and Fridays put out for grade 11 science
No,
class.
I meant in terms of me giving you a call tomorrow morning.
Oh, yeah. Anything after 10 to between 10
Okay.
and 1. I'm normally available.
Okay, cool. So I'll either speak to you later this afternoon or tomorrow morning
Yeah, no problem.
between 10 and 1.
Okay. As long as
Okay.
they've got this photograph also,
Yeah, we've got that
we have to
photograph.
continue. Yeah. Okay, excellent. Thank you.
Thanks so much, Charles.
No problem. Bye-bye.
Bye.
Bye.
Okay.